to be with you all. I'll just briefly say who I am. I'm an assistant professor of wildlife policy and management at the University of California, Berkeley, and currently serve as a senior advisor for wildlife conservation at the U.S. Department of Agriculture. I am the least experienced wolf, sort of scientist here. Three of us. Some proportion, less than half of my work has involved predator-prey interactions in North and South America. Some of that's been with wolves, some of that's been with mountain lions, and in every case, though, involving interactions with ungulates, which I've studied proportionally much more, than predator-prey interactions per se, but can nevertheless offer you some insights from my work on that topic of years. I appreciate the opportunity to visit with you all, firstly to share insights, but also to get together and listen to John and Matt, because you'd be surprised. We don't actually get to hear each other's story as often as you might think. So that's been valuable and fun. And what I'm going to do here, and let me try and get my slides up, is really, it was hard to think about, what would be most useful. We did get useful prompts from your facilitation kind of team, but still pretty broad. And so, really, I just decided to take you on a tour through my head a little bit on the topic of wolf ungulate interactions. And so, are you able to see my slides all right now?
Yes.
All right, great. So I'm going to start right where John left off. And actually, we didn't coordinate this, but I think it works out nicely. I thought I'd gloss over this really quickly until I heard some of the questions and discussion, which prompted me to want to say just a couple things. One, I think there can slip in an assumption when we're talking about the case of the northern herd that somehow having 20,000 elk is a useful or positive thing, and it is the case that almost no one involved in this case wanted there to be 20,000 elk in the northern herd of Yellowstone. And so we can draw on a lot of John's useful models, or we could just go talk to Montana Fish, Wildlife and Parks, who would tell us we were trying to hammer this elk population to get it down to a size that was not, destroying the range and the habitat that these animals, that was not eating into the principle, to use John's nice idea. And so it is simply the case that it was a management objective to use an incredibly intense hunter harvest to drive that elk decline. And then it was also useful that wolves came in and played a bit role for a while in perhaps in some of that. And so that's just a piece of context I really wanted to give you all, that was a management decision to deploy really high rates of hunter harvest to drive, to partly drive this elk decline. But really what I, and I want to tell you too, this is an elk herd that when it's outside Yellowstone National Park in north of the park in the Paradise Valley, has something like 10,000 elk hunters trying to get a piece of it. And so this is just a case with really intense, hunter harvest. And that's important for everybody to know when you're thinking about this case. So I just want to now John, I think, provided really important kind of ideas about these fluctuations over time and these different phases of top-down and bottom-up control. And I'm going to talk about space, and so the northern herd in the Greater Yellowstone Ecosystem, which I do a lot of work in, has been studied better than almost any other wolf ungulate system in the world, and yet most of that study has been in one part of the year round that particular elk herd, and there are a lot of other elk herds in the system. And so part of what I have wanted to do in my research, which has been motivated not as much by the predator-prey questions as by the questions about the ungulate populations themselves, but is nevertheless, I think, insightful for our purposes today, was just to try and understand elk in the Greater Yellowstone Ecosystem better and build some context. And so a lot of that work was done by just collaborating to aggregate movement data sets and then go and fill gaps with new GPS coloring around the ecosystem. And so this is kind of what that starts to look like when you pull a lot of this information. Depending on how you define sort of the ecosystem, in this case, it was, looking for herds that spend some of their time in either Yellowstone National Park, Grand Teton National Park, or adjacent national forests. We came up with about 16 major partially migratory herds, several, tens of thousands of elk involved in these movements. They're all partially migratory, and they, generally, if you look at this map, they're wintering in these outlying parts of the landscape, in the outer, portions of the map, and then they're moving in spring up into higher elevations in the core areas of the park. I just took a glimpse here to see, in one recent year, 2015, if you look at any of these individual herds, and the northern herd is there in green, sort of in the upper part of the map, you would find anywhere from 2 to 12 wolf packs per herd, kind of associating with those elk as their primary prey, and about 40 or 45, somewhere in their packs in total associated with these elk herds. And so it can be said that there is a wolf-elk interaction in every case of an elk herd that you're looking at on this map. So what I'm going to show you now let's look at the northern herd as one of these herds, where we're looking at the abundance of elk from state surveys over time. And I too am behind on updating figures, but basically you can see generally from this figure that there's a lot of different situations going on, a lot of different, there's elk declining in some herds, particularly the northern herd. But you can also see cases where these populations are relatively stable, or even going through periods of increase since 1995, when wolves were reintroduced. So just what to notice here, even with multiple wolf packs associating with each of these herds, there's still tens of thousands of elk in the system. Many of these herds have not declined since wolf reintroduction, although I want to be very careful to say, and I'm not going to show you all the details, but sometimes the distribution of elk within one of those herds represented by one of those lines has changed, and sometimes that's been associated with wolves or other predators, even if the total overall abundance of those elk in that herd unit. And in some cases, hunter opportunity may have declined, even though the abundance of the herd has remained the same, because managers are titrating that harvest to protect the abundance of the herd in some cases, and things like that. So I just want to tell you, there is not a Yellowstone wolf elk relationship. There are many different Yellowstone wolf elk relationships, and I expect this to be true, as John has eloquently stated in a variety of ways about the complexity of any system we look at. This will be true almost anywhere we look at this kind of predator-prey relationship. So it becomes a question of, what sets of conditions tend to generate different kinds of outcomes. And I think it's Matt's who's going to give you a lot more information about sort of what conditions prey vulnerability, terrain, snow, other things might come together to influence, what kind of relationship we get for wolf-elk interactions. What I want to do for the next 10 minutes or so is just zoom in on the ones I've actually studied, because there I'm just broadly hand-waving and generalizing about some trends in the ecosystem and some general observations, and trying to put the case of the northern herd in context for you. But I have studied more closely a couple of other partially migratory herds in the system. So there's the northern herd again. Here's the Clark's Fork elk herd to the east. This is a herd that I looked at back in my grad school days, mostly with questions about changes in the herd and what factors might be attributed as drivers of those changes. And one of the things that was going on in the Clark's Fork herd when I started, and by the way, this is a herd of about 5,000 elk. Up at the top right, what you can see is GPS locations from this study of resident elk in kind of white or gray, and then these migratory elk that kind of co-occur in the herd that winter in to some degree overlapping areas, but then summer in distinct areas. I'll talk more about that in a minute. And then you have these wolf packs in different colors that associate with the Clark during the period of this study. And what was going on at that time, the state in particular was interested in understanding better, was this kind of long-term decline in the number of calves, the calf-cow ratio. You can see in black, in particular, the migratory elk having this declining cow-calf ratio down to 12, 15 calves per 100 cows, which is a level that managers get concerned about in terms of the sustainability of the population over time. And so we were looking at that. It was very logical to look at the influence of wolves because, gee, they showed up and then, the calf-cow ratio started really declining in that migratory, more backcountry kind of part of the herd. The thing is, it was pretty apparent early on from collaring of elk in this herd that adults were not being heavily impacted by wolves. So adult female survival was above 90% in the Clark's Fork herd, both among the migrants and the residents. And then also Yellowstone, folks over in Yellowstone had conveniently studied calf mortality, cause-specific calf mortality of elk over it in areas that are used by a migratory Clark's Fork elk. And fewer than 12% of calf mortalities were, or fewer than 12%, I should say, this is wrong on the slide, fewer than 12% of calf sort of loss was attributed to wolves in those studies. And so this wasn't really sufficient to explain all of this decline in calf numbers. And so this led us on what later became a very costly kind of rabbit hole, but I think proved to be a useful component of the study, which was to explore this hypothesis that a lot of people had, from ecologists just to hunters and that wolves as this predator on the landscape were influencing the production of calves by nutritional stress on elk, risk effects, fear effects, this kind of thing. So we looked really closely at that. And the hypothesis here that a lot of people had, and so the one we tested, was that in the presence of wolves, elk are going to move around at higher rates, use more energy, displace away from preferred foraging habitats, and have higher rates of vigilance that reduce their amount of time feeding, and maybe they spent more time in understory that they could forage on, and this kind of thing. And so the idea here was that because of these behaviors that had a cost of some kind, that whereas elk would normally cows would be losing body fat all winter, that they would lose it faster under this risk of wolf predation, and then they would lose their pregnancies. This was a prominent hypothesis when we started this work. And so just very briefly, the way that we tested that was we got a bunch of field assistants, one of whom was Trent Ruzin, who's part of your crew in Washington now and did great work for me back then. And we went out and we got GPS data from 15 wolves across these 4 packs, 81 cow elk, all on this 3-hour fixed rate. And we got these paired locations where we could look at things about the interactions and the behavioral responses of elk when they were in a certain proximity to wolves. We also got a bunch of more detailed data. So like when you're looking at 3-hour fixed rates, there's a lot that goes on, other than movements, within that interval. And so we wanted to look at more detailed time budgets. And so we went around looking at, the proportionate time that these elk cows were vigilant and feeding and doing other things in winter. We built up a pretty good sample, and I'll just tell you what we saw. What we saw was that Yes, movement rate, daily displacement, vigilance, all increased when wolves came within about a kilometer of elk. But whenever we looked at the increase, and you can see that couple of figures here, it was pretty minor. So we had, increase of some, 20 or 30 meters per hour in the movement of elk following on a day in which there was one of these encounters. We had a couple percent increase in the vigilance rate within the same distance. And we had other results like that. Consistently, 1 kilometer was this meaningful distance. And the thing was that those encounters, not only did they incur smaller behavioral responses than we were told to expect by other scientists and by everybody else, but they didn't occur very often, right? Because it turns out this is all happening over a big area. Wolves are moving around through this large area occupied by this elk herd. And so each individual elk would only experience one of these encounters every 9 days or so. Maximum, I think, was every 4 days for these migratory elk in really high risk areas. And so implication is relatively small behavioral responses occurring not that frequently relative to what you might expect going into this, what I expected going into this. We then worked, or throughout this whole thing, we worked with some folks, John and Rachel Cook, who are not far from some of you in LeGrand, Oregon, and have this method of rapidly assessing elk body fat in the field. And so we worked with them and we tracked a bunch of these elk cows and looked at their body fat changing through time. And this is just to represent, I think we had about 40 cows that we focused on here. This is just 5 of them. And I'm glossing over some details here, but what you can see is body fat, lower in the winter, obviously increasing dramatically through the growing season, dropping back down through the next winter and so on. And for our purposes in this work, we were interested in, is this variation in late winter in March and these body fat levels of elk cows related to something about how many of these 1 kilometer encounters occur that invoke a set of avoidance behaviors or reactions. And I'm just going to tell you, there were no associations at all there between wolves and body fat, wolves and pregnancy. Body fat and pregnancy of elk were completely determined by how good the summer, conditions were the previous summer. And there wasn't much that sort of knocked an elk cow off her trajectory that she had gotten on with her summer foraging and reproductive status in the previous year. So not really an effect. Of course, I guess the upshot here is, wolves influence elk behavior, but maybe not as strongly and with as many consequences physiologically, nutritionally as we were, as was suggested at the onset of this work, and as we expected we might find. So, here I am telling you what, essentially giving you no answer to why there were fewer calves in this elk herd, because we didn't find that the risk kind of pathway helped us get closer to an answer. What's important in trying to seek one is to know that these elk, like I said, are partially migratory. So particularly these elk that are shown in black here, they're going up 30 up to 60 miles into the upper Lamar River system inside Yellowstone National Park in the summer and fall. Importantly, that's when they often give birth, or they bring a relatively newborn calf with them on that migration. And so the population is in a sense vulnerable, if you will, because they've got a lot of vulnerable calves with them at that time. And so what was going on with those? Well, in short, like I said, wolves kill about, in earlier studies led by folks in the park, about 12% of them are calves, but bears, particularly grizzly bears, were killing about 40% of the marked calves. And so you could see very quickly, just looking at these data that came out, kind of in the middle of our study, that, gee, you don't have to look very far to see a pretty strong role of this other predator in affecting the number of calves the decline of calves that's being hypothetically attributed to wolves in this system. This was an increase. Well, bears have also been recovering in the system, all the while wolves received the attention, similar growth in bear numbers over the same period of time. And so this is a result of that growth. I will just quickly say, we also looked at, habitat conditions, broadly speaking, and what we saw is that the period of summer green up during a couple of decades leading up to our study had been reduced by a series of really dry and importantly, really hot summers. And so we didn't have great data on sort of fine scale foraging and nutrition of elk, but we thought this was probably affecting the pregnancy rate and a little bit the calf-cow ratio of these elk, because it was hurting the ability of cows that had a calf to get pregnant again and have another calf immediately the following year. So I won't dig too deep into that, but that's kind of what we saw and thought and inferred. I want to just make one brief statement now that I've told you all that, and we've touched on the northern herd and the Clarksville herd, about the Cody Elk Herd. Cody Elk Herd is a neighboring herd, about 6,000 elk in this herd. I have done other kinds of work in the Cody Elk Herd. We've got some recent predation study that we're still kind of writing up. But a lot of the work here has just been looking at migration patterns. I should go back, and if you look at those blue lines, this is parts of this herd make one of the longest distance migrations by elk that we know of really anywhere. And so it's been interesting to ask questions about the migration behavior there. And so I'm not going to base this on lots of, detailed results about studies of wolf-elk interactions. But what I'm just going to tell you is, having spent a ton of time all over the place in the year-round range of this elk herd, here we've got a herd of about 6,000. It's got about 8 packs of wolves. Some of the highest grizzly bear densities in America are in the lower 48 states. But it's got 20 cows per 100 cows. It's had no decline in abundance. It's over objective. It's had very little decline in hunting opportunity, except for a couple sort of small watersheds within this larger landscape where there's been some shift in elk distribution. And so I'll come back to this, but one of the things that's really interesting to me about all of this is that we tend to flock to the cases where we see a decline and where wolves are having some impact, and we don't give much study to cases where we don't see those kinds of effects, because it's not as interesting or urgent for us to understand that. I guess I'm jumping the gun on some lessons learned with that last comment, but a few assorted things that I think emerge from some of my work and observations over the years is, one, when wolves recolonized naturally, we all, from scientists to many stakeholders to the public, want to know what the effect of wolves is, but that's really can become misleading when we're in a multi system. And so it's worth, kind of guarding against the oversimplification of these systems when we set up studies or communicate to the public. When we treat prey as just something that predators eat, we're going to overlook some really important stuff, like, hey, they migrate 80 miles to a different place, far from all these wolf-elk interactions on winter range, and experience different things like bears and drought on summer ranges. And if we don't pay attention to what the prey are doing and have a good understanding, then we're probably not going to ask the right questions or make the right inferences in our predator-prey studies. And relatedly, kind of totally reasonable hypothesis about these wolf predation risk effects. Big caveat, I only studied it in one place, so there may be other things going on elsewhere. But I think it really fell apart partly because this is a big landscape. The wolves and elk are distributed widely across it. There simply is not a wolf behind every tree interacting with every elk. Those interactions are infrequent, even when there's a fair few wolves. And when it comes to elk, maybe not as much deer, it's pretty hard to kill them. So we can't underestimate these prey either. And we have to make them a part of our thinking about these interactions and think about other biology and life history that's going to make them resilient to some of these effects. How wolves impact ungulate abundance and harvest really just, it depends on where we look. And like I just said, I think there are places where these impacts occur. There are other places where they are fairly minimal. We tend to look where they occur because we have limited resources and we're accountable to stakeholders who want to know answers about changes in the numbers of these game animals. And so I think we have to be careful about just introducing bias at the level of where we study these interactions. Hard lesson I've learned anyway. And I think while another topic, John touched on it, I think it's important, I'll just use an example, I'll stick to what I know. In the Clark's Fork herd, not too long after I did that work, wolf hunting was introduced, but the state, because of some of the work we did, was quite careful, and I think fruitfully so, not to tie the idea of harvest to that we're going to get some big return with recovery and calf numbers. That harvest was introduced basically to create opportunity for some people who wanted to hunt wolves. And I think that that's an important distinction because we can really mislead the public, I think, by saying, we know for all the reasons John told you, we know that if we have X amount of wolf harvest, we're going to get some significant investment in terms of our calf numbers or whatever. That can just be very tricky. And so perhaps for managers, there's the question not only of whether wolf numbers are limited, but how that's communicated about curious and interested public. So I'm going to leave with this idea that I've sort of thrown all this stuff out, but I think actually some of what Matt's going to have to offer is some of the most important information, because we simply cannot go and study every single case in which wolves and prey interact. And so really strategically, it becomes a question of how do we study these interactions to generate insights about what conditions generate what kind of, and then we'll be better positioned to explain and guess at why these different outcomes are happening in different settings. And I think that's been one of the important strengths of all the work in the Northern herd, is to help us start to get rules of engagement, rules of the road that explain wolf-elk interactions. So I think it's great you all are having these conversations, relatively early on. A lot of people paid for a lot of this work. It costs a lot, so you have to be strategic and deploy resources strategically, right? And so good for you for thinking about how you might do that. And lastly, it also has a social cost. So all this work costs a lot in terms of, these are landowners across the distribution of these elk herds, just to illustrate the idea that everybody has a stake. And so if you're going to do this, how do you do it strategically to generate the kinds of insights you want? Because the research involves a lot of emotion and stakeholder involvement. Thanks.